or we can just do the tricky stuff.
Yeah, can we just do the hard stuff? Because I think I like mostly understood it.
Yeah, I expected as much. This is 1, this is 2, and then we'll go for 3. Yes. Okay. It's gonna be fine. Yes, maximum or limiting value. F max is equal to mu r. Yep. So that's when it's just on the verge of sliding or whatever. Okay, how about this?
So it tells you that the coefficient of friction is 0.2, but you have to find the resultant force first. Oh, it doesn't give you acceleration, so
Uh,
do you find what F is?
so we're told, so F equals mu r?
Yeah. Wait, is it F equals mu r or F max equals mu r?
So I'm just using that for short, but well, it's technically it's not gonna be. That's only if it is the maximum. If it was just in general, it would just be like F is less than or equal to something like that.
Yeah.
But in this case, just the friction in general, mu r. So you wanted the resultant, was it?
Yeah. Because
So that's r. Any idea about resultant?
hmm?
Any idea what the resultant is?
Oh, I got 49 minus r is equal to 5a, but I don't know what to do next. Because you have to do sum of f equals ma.
Say it again, sorry. 49.
Minus r
Mm-hmm.
is equal to 5a.
Very, very, very wrong.
Wrong. Oh.
So this is one direction. This is a different direction.
Yeah, I did. I only did the like upwards and like the vertical direction.
A particle of mass 5 is being pulled along a rough horizontal surface. So this is 90 degrees to it.
Yeah.
So that would be like they're different directions.
Yeah,
Uh,
I didn't do the horizontal direction. I only did the vertical one.
where did the 5a come from?
Because you have to use sum of f equals ma, and 5's the mass.
Different direction.
Oh, it's not moving, so you can use 0. Oh, okay. I confused myself. Oh, so R is equal to 49 Newton.
5g basically.
Yeah, and then F. got F is equal to 9.8 N. Yeah.
9.8 N.
Yeah. Oh, now you can do sum of F equals ma to find what the acceleration is, I think. I got A is equal to 2.04.
0.04. And was that what, 20 minus F
Yeah.
equals 5A?
Yeah.
Okay. And so that is A. Let us see. So 2.0 to that, and then it's just as simple as 5G. Yep. So they have to be going in the same direction.
Yeah, I just got confused with sum of F equals ma and like resolving forces.
Okay, that's grand. Okay. How about these?
So P is equal to 10. So you have to find the resultant force first, which is just 49 newtons, I think. Then you multiply by 0.4, which is 19.6. But that's F max. So if it's only 10 newtons, then F is equal to 10 newtons as well.
So F is, was it less than or equal to, what was it, 19.6?
Yeah.
And in this case, it is 10. Okay.
So in the next two, it would be the friction would just be 19.6 for like the next ones as well.
Well done.
So the acceleration, that's just sum of F equals ma. So so for the first one, I got A is equal to 0.
For A.
Yeah, for A.
Okay.
Then the second one is also going to be A is equal to 0.
Okay.
So the forces would be balanced. And the third one should have an acceleration. Um, 2.08 for the third one.
And that's 30 minus F equals
5A.
5A. And F was 19.6?
Yeah.
Just put that there. Friction only needs to be 10. Equilibrium. Friction, and then 2.1 it rounds to. Yep, fine. Any questions about that?
No.
Good.
Oh, I hate these ones.
Okay.
I don't know how to do this one.
Sketch. Let's see. So it's a mass 2. And it's sliding down. Maybe I'll just do it like this. Okay. And that's sliding down a slope. 30 degrees. Given that the acceleration is 1, find the coefficient of friction between the particle and the slope. So what's this going to be?
2G.
That is 2G. And what is this going to be?
Just like the force that's pulling it down.
The force. 2G sine 30.
Oh yeah, okay. And then wait, wouldn't the vertical force be 2G cos 30? Like the reaction force?
Do you mean like this way?
Yeah.
Yep.
That 2G cos 30. Oh, okay. I understand. So you have to do sum of F equals M. Do you have to do that to find? Yeah, because then you can find the friction force.
Mm-hmm.
Since you know that 2G sine 30 minus F is equal to 2, because MA is 2.
Hold on. M is 2.
Yeah, and then A is 1. So
Oh, sorry, they do tell you that. Yep.
yeah. So then you know.
So we can just get F.
Yeah, 2G sine 30 minus 2 is equal to F. F is 7.8 newtons. So then, you know what F is. You can find what the reaction force is. Oh wait, you know what the reaction force is. It's 2G cos 30.
Mm-hmm.
So 7.8 divided by 2G cos 30 would give you what mu is.
Is it the other way around? 2G cos 30 over...
Why would it be?
Oh, no. My mistake. Sorry, go on. I just wrote it in the wrong place. 7.8.
It's like a weird answer, but...
Force is 2G cos 30. Go on.
0.46. I mean, the exact answer is like 13 root 3 over 49.
13 root 3 over 49. And that's roughly...
0.46.
And coefficient of friction often looks something like that. And yeah, it's got no unit. 0.46 roughly. Yes, what we'll see. So going down the hill, it is.
I just like when it's like on a slope, I get confused like which force is sine and like which is cos. Like I can't always tell.
So basically, the one that's going along the slope is sine.
Yeah.
So usually the horizontal force is cos. When it's sloped, the in relation to the block, the horizontal will be sine, and
Okay.
this way will be cos. But it's just if you're ever stuck, you could just like this line here, you can just kind of do sine 30 cos, and do it that way. Opposite hypotenuse. So,
Okay.
oops. So the sine of 30 is the opposite over the hypotenuse, and you can do it that way. Okay, let us see. Yep.
I understand that bit. Like,
Slope time.
wait, I don't understand that part. Like the triangle.
Uh, I wouldn't dwell on it too much, but let us see. So, you can make a triangle.
Mm-hmm.
You cheeking this man wanting to skip. Yeah. So, usually horizontally is adjacent over hypotenuse.
Yeah.
And so when it's on a flat surface, it is the cos one. It is hypotenuse cos theta.
Okay.
So the cos of the angle is the adjacent over the hypotenuse. The hypotenuse is the force, and when you make that the subject, if you times both sides by the hypotenuse, you get the adjacent. Is so this like
Okay. So that's it's like 2g cos theta because it's like you're timesing by 2g.
yeah, so it's usually like sine theta is opposite over hypotenuse, but you times through to get rid of the fraction.
So, okay, yeah, I get it now.
Okay.
I didn't know.
Okay. Yes.
I think we did this for like 2 lessons.
It's yeah, I don't blame anyone for kind of skimming over. I mean, the
That's
horizontal.
our teacher's like style. Like she'll teach something for like 5 minutes and then we'll do like 2 lessons of questions and like that's done.
What was it? The way I do it is like horizontal is cos theta normally, but when it's sloped horizontal in relation to the box is sine theta.
Wait, so normally it would be, what do you mean by normally it would be cos?
So if it's on a flat surface, so if it's on a
Why
flat,
do you have sine and cos on a flat surface? Why would you need them?
you if it is being pulled diagonally,
Oh, okay. Yeah.
yeah, and then when
So
it's
normally when it's being pulled diagonally, the horizontal one is cos.
yes,
Okay.
and when it's kind of falling diagonally, the
It,
the box is horizontal is sine.
okay.
Yeah, you can prove it, but it's
Yeah,
easier to just
to do that. Okay. Slope. Drawing time. Our teacher loves diagrams. Like you have to draw one.
yeah, they really help. But
Yeah, it does actually help, but like last year I did not want to do that.
I just don't like to start with one because then I'm kind of that might be helping too much.
got F is equal to 1.143. 143 newtons. That does not look right there.
So that might be F, but they wanted the coefficient of friction.
Yeah, I'm working it out now. So you just have to divide by R. Um, 0.241.
They say 242. Did you round too early?
No, I got 0.24149.
241.
It's probably because I rounded like my friction force.
So don't round your friction force. Okay, so keep your working out to always 2 more than you need to. So if this is going to be 3 sig fig, then keep this 2.5, etc. And that is why all that hard work and you'd lose a mark. You'd lose a third of the marks. There you go. Let us see this one. Rough slope.
I did.
Oh, this might be worth doing. Yeah, 4 marker. Let's try this one.
I don't understand. If the particle's sliding down, but the force is pulling the particle up, does that mean the force P is the friction force?
I just assumed it was a separate force.
That's what I thought as well, but it says the particle sliding down, but then it says the force is attempting to pull the particle up the slope. So
all that tells me is that P plus F is less than the opposite force, the opposing force.
what's the opposing force?
The what would it be in this case? Oh, you diagramming this man, I did. So 2. 20 degrees.
Mm-hmm.
So we've got 2 forces going on. We've got a force P, we've got our usual friction, and what is this force going to be?
2g sine 20.
So all that tells me is that 2g sine 20 is bigger than P plus F.
Then big P plus F. Okay. So the first thing you have to do is find what F is. So you know what mu is and you know what R is. So you just have to multiply them together. R is 2g cos 20. And you get and that's 5.52539. Then you want to find P. Oh, then you have to resolve like the forces. Wait, if the direction of the acceleration is like negative when you resolve, then do you have to put the acceleration as negative as well?
Uh, I suppose, but just as long as. So what direction is it accelerating?
Like down the slope.
Okay, so long as everything going down the slope is positive, everything going up the slope is negative, then it'll all work out.
I did the other way around, like
It'll
everything
all it'll all
going
work out.
negative. So if you do like going down is negative, then the acceleration has to be negative, right?
Yeah.
Okay, just wasn't sure. Oh, but then P came out as P is meant to be negative. Okay.
What's P?
Um, Wait, if the force comes out as negative, can you just ignore the negative sign because it's because of the direction? Or do you have to put the force as negative, like 0.778?
Negative 0.778. Um,
Can you like ignore the negative sign or
you kind of feel like you could say 0.778 up the slope, something like
okay.
that.
Or
You usually going down is negative and going up is positive. So yeah.
I think I resolved the wrong way.
Well, there you go. The force is P is 0.778 newtons. So yeah, you could
So
say
you just ignore the negative.
yeah, it's going like up the slope. Something
Yeah.
like that.
Well, our teacher told us that when you resolve forces, like you have to put the direction like in an arrow next to it, like in brackets.
So yeah, it's good practice to do that. So
Yeah,
you
I do that usually. So I
in
think it's okay.
in my case, I'd have to write like resolving and then like that.
Uh, that's what I did, but I did it like to the left instead for some reason.
It's all
Yeah.
good. Same answer.
So
Let's hang on a second. Was this one okay? Yeah, I think you were good for this one. Yes, you've just got two. Don't worry about these. Even though there's two forces, it can still be less than this
yeah,
one force. Coefficient of friction between the surfaces. That
don't
how's
do this question. I can only tell.
yay speed. Okay, let's do it. Oh, it's horizontal. Okay. Four. Okay, an idea here.
No.
My guess is that speed will have something to do with suvat, finding v, or it could just be
But you don't know the acceleration, so how can you? Oh,
if only you had several formulas for finding acceleration.
we do. Okay, you don't know what S is. If it was Surat, you don't know what S is. You know U is 0, and you know T is 5. That's all you know.
Okay, and my guess. Oh, I won't spoil the surprise. Okay, U is 0, starts from rest.
T is 5.
T is 5.
Yeah, I don't know anything else.
Aha. What are we trying to find?
Speed.
So, what in terms of suv, would that be?
Wouldn't that just be final velocity, so V?
Yes. And let's see, can we find A?
No.
You and your no.
So, because you only know one force in each direction.
Which force do you not know?
R and F. Wait, but you could resolve to find. No, you can't. No, you can. You can resolve to find R, because R minus 0.2 G is equal to 0, because it's not moving in the vertical direction.
Mm-hmm.
So R is equal to 0.2 G. R is equal to 1.96 newtons. And then once you know R, you can find F as well.
Mm-hmm.
Oh, it's 1.96, not 1.16.
Chicken does,
man. 0.784 newtons for F. Oh, yeah.
I'm gonna need 2 more.
Oh, that's literally the answer. Like,
Oh, exactly.
Yeah.
Okay.
Okay. So since you know like a lot of forces, you can do sum of F equals ma to find A. So you can do 4 minus 0.784 is equal to 0.2A. I got A is equal to 16.08. That seems really big.
One more? Or is it exactly 16.08?
Yeah, it's exactly 16.08.
Okay.
So, yeah, you could find V now. V equals ut plus half at squared. Is that right? No, that's S equals. I don't know the formula by heart. Oh, okay. So V is just equal to 16.08 times 5. And then that's 80.4.
And it seemed like it would be something like that.
Sorry, why did I write newtons? The length of time it takes the box to come to rest. Oh, I really don't know how to do the second one.
Suva.
But U and V would both be 0?
For the initial, so there's like 2 legs to this journey. The first leg, U was 0, and we just found V. For the second leg, what is U?
Oh, U is 80.4.
Yeah.
And then V is 0. And then you don't care about S. A is the same. A is the same, right?
If A is the same, then how will it ever stop?
So A is not the same.
Yep.
But I thought it's constant acceleration, so A has to be the same.
A was the same. Then they removed the force.
But
So
you found this. Oh, so there's no force. How did you find A then?
if only you had several formulas for finding A that you just used in part A.
Oh, V equals U plus AT. Yeah. 0 is equal to. But you don't know A or T.
If only you knew several formulas for A that you just used in part A.
Oh, sum of F equals MA.
That's one of them.
I don't know any others.
Sum of
Yeah,
F.
you can't use V equals U plus AT
I agree.
because you don't know A or T.
What is F?
F 0.78 F equals MA. Force, so how do you.
Oh yeah. So all the forces are removed because that was friction, is it?
Yeah. You'd still have like 0.2 G and R, but I don't think that counts.
You'd still have that. Let
If
us see.
that force is removed, then friction would be removed as well. There wouldn't be any because it's not trying to move.
Yeah. This requires some modeling or something. I suppose that's what the topic is. The length of time it takes the box to come to rest from the instant the force is removed. At that instant, U is 80.4. We know V is 0. We don't know S. We don't know T. But we need A. We need the rate at which it is decelerating. F equals MA. Do we assume that F is 0.784? Yes, we do.
But there's no friction, so how can F be?
So this 4 is taken away,
Mm-hmm.
but I believe this remains.
But if there's no force on the other side, because friction is only as big as it needs to be to stop motion. So if there's no motion, then
So
you have a friction force.
so when it stops, when V becomes 0, then then F will also become 0, but
Mm.
but it'll kind of slide for a bit.
Oh, is this like the limiting velocity, or is that something different?
That's something different, I think.
Okay,
I hope to God it isn't that.
something to do with friction, but I don't remember what it was.
So I think it's this one. Let's try this one.
Okay, so do you just assume that it's 0.784?
Yeah. I'm going to say minus 0.784.
Why?
Because it's going left.
Okay. Oh yeah, because then the acceleration would be negative as well.
Yeah.
Minus 3.92.
Okay.
Oh, now you could do V equals U plus AT.
Yep.
Um, 20.51 seconds. If they don't tell, oh wait, they do tell you that it's seconds, but if they don't tell you in a question, like, can you just assume that it's meters per second, or should you just not put a unit on?
For SUVAT, you have to use the standard international whatever it's called units, which is kilos, seconds, meters per second,
Okay, so you can
meters per
assume
second squared.
it's meters per second if they don't specifically tell you.
So just looking at it, let's see. So this unit is in seconds.
Yeah, but if it doesn't tell you the question, can you just assume?
They have to tell you.
Okay.
They can't say like after 5 or something. 20.5 and 80.4. Great. So this is like two different stages, a journey with two different stages. The first stage, there's, 2 forces. Second stage, there's 1 force. Something that's going to come up a lot is the V of stage 1 is the U of stage 2. And so you have to find the V of stage 1 to get the U of stage 2. Yes, F equals ma. So the frictional force continues to act until until it stops. So in the real world, maybe this friction will slowly go down as this thing slows down. But, we're modeling, so we're using a simplified model that it's just a constant force. Any questions there?
No. I mean, it was hard, but like...
Yep. And they only get harder.
Why? Oh, this is one where the force is like acting at an angle.
Mm-hmm.
So, oh, it's like when you resolve, you have to do it like, you have to include the P force, right?
Mm-hmm.
So like when you try and find R, then you have to do R plus cos, wait, no, plus sine. So plus 10 sine 45 minus 10g is equal to 0. Is that right?
I believe it would be R plus P sine 45.
Oh yeah, not 10. Yeah. Then you have 2 unknowns. So how are you meant to find?
We gotta keep looking. Find the value of P. How about, so that's resolving vertically?
Yeah.
Try it.
So sum of f equals ma. You could do. So you would just do the same. Would it still be r plus p sine 45 minus 10g if you're doing sum of f?
What would it be equal to?
3, because 10 times 0.3 is 3. It's accelerating horizontally, so you can't do...
Yeah.
You can't use the vertical forces, can you?
Yeah, exactly.
So f... Wait, no. So p cos 45 minus f is equal to 0.3 times 10. You still have 2 unknowns, so I'm really confused. Do you have to do simultaneous equations?
Looks like it.
You can't even do that though, because you have like 3 unknowns and 2 equations.
And the A is 0.3. So pick some other equation then. So you get 3 equations with 3 unknowns.
Yeah. Well, f equals mu r.
That'll do.
So f equals 0.1 r. And then you can just substitute 0.19, the second equation, then you can use simultaneous equations.
Yep. I'll just be a second.
And we have to find the system. Now, when I tried to solve the simultaneous equation, I got p sine 45 plus 10p cos 45 is equal to 128.
Okay.
So I get to solve that now. Yay.
You should be able to do it with a calculator.
I don't like doing simultaneous equations and that.
They're so easy. Sine 45 is root 2 over 2.
Yeah.
Cos 45 is the same thing. Okay.
It's actually a really hard question. Oh, it's 7 marks. No wonder. I got P is equal to 16.456 newtons.
16.5. 16.5. Yep.
Right.
Great. Yeah, so it was just basically 3 equations, 3 unknowns. Any questions there?
No, not really. I mean, like, once you figure out what to do, it's not that hard, but it's like figuring out what to do is hard.
So basically, resolve vertically, you're like, oh, I've got 2 unknowns. I have to do it again. Resolve horizontally, oh, I've still got 2 unknowns, because they both involve P, but they're 2 different ones.
Yeah.
And they gave you the coefficient of friction. So
That's what I thought as well.
Yeah, they wouldn't give it to you for nothing.
Oh no, this looks really hard.
Yay.
Oh, not yay. Okay. So the downward force would be, would it just, I don't know what the downward force would be.
It is the this will be sine.
Yeah.
So sine theta and then times by mg.
Why would it be mg? Oh yeah, okay.
Yeah, I tried to not tell you too explicitly, but it's just a...
And then the top one would be cos theta mg.
Yeah.
The one going upwards. And then f. So sum of f equals ma. And then f is equal to mu cos theta mg.
For
the friction force, wouldn't it be equal to mu times cos theta mg because that's the reaction force.
Yeah.
So then you have to do cos theta mg minus mg. I think I'm doing it wrong. Okay.
Oh, sorry. It's kind of difficult to not help with this question because it's just finding a formula for it.
I think I kind of got it.
Okay.
But I'm still like sort of doing it, so. Oh, I got it! Yay!
Yeah. So just divide everything by m.
Yeah, and then factorize out g.
Yeah.
Yeah, that's what I have left to do. Oh, but I got mu cos theta minus sine theta. Could that be wrong?
You in that case that would be equal to minus a, I believe. It depends on what way you're resolving.
I just did my didn't put minus a.
It's sliding down the rough slope.
Yeah, like you do it.
Yeah, so if it's going down the slope, then mg sine theta and a would have the same sign. They're both going in the same direction, and f is going in the opposite direction.
Yeah, I think I didn't put a on my diagram, so I got confused. Okay, I'm just writing it out again, so I know how to do it, but I understand how to do it though.
And it's pretty good. It's a formula. So if you had a question like this and they said find a, you just do g times the difference between sine theta and mu times cos theta.
Oh, I saw. Okay, it's minus a. Done.
Grand.
So if I got minus a and then I change the signs in the next line, that's okay to do that, right?
Yeah.
You don't get marks taken off for resolving the wrong way.
No. It's you're not. There's no such thing as resolving the wrong way. You were just resolving up the hill. You just times both sides by -1.
Okay.
You know, it's in the same way as you divided both sides by m, times both sides by -1. So I just want to see if there's any major thing. Oh no, does that? Didn't work it. Good. That was the very last one there. Yes. So this was the last one, which is just kind of a similar idea. It's grand. Okay. Let us see. So friction. So you're obsessed with this equals 0 thing. I just look at it as mg equals r when it's horizontal.
Oh, okay.
Nothing more than that.
Yeah.
F max is equal to mu r, and
what's the limiting value, or the limiting velocity or something?
Let's not even go there. Limiting value in this case is just F max. That's what they're talking about.
Okay, but isn't there an actual thing called the limiting velocity that's different, or the limiting something?
I leave those questions for the philosophers. I'm sure there probably is
something called. There's something where if they tell you that means it's about to start sliding or something.
Yeah.
It's cool, but I forgot what it's called. I can probably check.
So that has a lot to do with F max when it's equal to 0.
we did. Oh, limiting equilibrium when the friction force is equal to F max, the object is about to slide.
Yeah.
Forces are balanced.
Yeah.
Okay, that's what it is.
Phew, you and your limiting velocity.
I don't know, I forgot what it was called.
Let us see. Yes, so
Just like last week.
if you're resolve in the same direction. So
Okay.
yeah,
Okay.
if they're perpendicular to each other, then like it'll be 0 and going the other way. This one, yeah, find it for one, sub it into the other. Yeah, you're good there. Yes, so horizontally, when it's horizontal, it is F cos theta. When it is on a slope, it will be F sine theta. Or I suppose, no. Let's just say as F sine theta, because this is the force. Yeah.
But then, like the force is acting as at an angle, it's the other way around, right?
Yeah. So
cos is horizontal and sine is vertical.
yes.
Okay.
That's when
I'm
it's.
going to forget that, but
That's when it's on horizontal ground.
yeah.
Mu, I think that was okay. Yep, diagrams help. This one. Yes, keep it to 5 sig fig until the very end and just watch your signs. So if one thing, if they're going in the same direction.
Yeah, you have to add them.
Yep. This one, two separate legs, very commonly, like 2 different stages, very commonly the V of stage 1 is the U of stage 2, and they'll use that in some way. Other than that, it's Suvat. I think that was okay. So this one, yes, going across P cos 45. So the horizontal for this box is cos. If it was on a slope, the horizontal for the box would be sine.
I feel like I remember this one easier because it's like, it looks more like a triangle. I don't really know how to explain it, but like, I remember this one better, like that when there's an angle.
Everyone remembers this one better.
At an angle, yeah.
Horizontal is easier.
The other one is opposite.
Yeah, at an inclined plane, yeah, they switch. This one, yeah, had 3 equations, 3 unknowns. Other than that, just keep going until you find. They gave you the coefficient of friction, and so you could use that with F equals mu r, yeah, to get an extra F and R. And then this one was about just kind of formulating the formula in general.
Yeah.
And so in general, acceleration is sine theta minus mu times cos theta, and then times your answer by g. Yeah, how was that for you, Amogha?
Pretty good.
Any topic in particular you want to do next time?
At the end of like the normal distribution topic, we did something called. Hold on. Where is it? Wait.
Continuity correction or something like that, is it?
It was called like rank something.
Spearman rank correlation coefficient?
Kind of, yes.
Maybe not.
Just called rank. I'm just trying to find. Okay, yeah, I found it. Yeah, Spearman's rank correlation coefficient.
Okay.
Hypothesis test. I sort of get it. I just want to go over like the hard parts of normal distribution because I have a test next week.
Coefficient.
And we did something called hypothesis testing for correlation and association, and I don't know what that is.
Yeah. Hypothesis testing with normal distribution, basically. Say it again, sorry. Hypothesis testing, what was it?
For correlation and association. I don't know what it is, but it's like something called rho equals 0. Something.
Yeah. It's basically just hypothesis testing with the normal distribution.
Okay. But yeah.
Yeah. Any questions from you in general?
No.
All right. Well done, Amogha. You did great. I look
You.
forward to chatting again next week.
Thank you. Bye.
Have a good week. Goodbye.